Have you ever wondered how your web browser literally loads a web page in seconds? Or how applications interact with servers which are spread across the world without stepping into each other's stores? If not, welcome to the world of ports. You see our laptops, any kind of device, they are probably running hundreds or thousands of tiny conversations in them. And each conversation or each network connection has a different port number. Ports are usually the most important networking concepts, but they are also one of the most misunderstood concepts. So in this video, I'll be explaining what ports are, how they work, which layer of the TCP and the IP model is responsible for assigning the port numbers, what are source port numbers, what are destination port numbers, and also a complete walkthrough of what goes on behind the scenes whenever we search for a particular web page or search for something on a web browser. What role does ports play in such a case? Without further ado, let's get started. Now I hope my presentation is up on the screen and you should be able to see two devices. Let's name them A and B, and all the emoticons that are hovering over the devices are symbolic of the connections or the applications, the services that are running on each of those devices or the tabs that are opened on those devices. Now I have a question for you. And I think by the time this presentation ends, you will have the answer to it. But I still want you to think on it. So if I send a WhatsApp message from device A, which is intended to device B, why does the WhatsApp message always land on the WhatsApp tab of device B? It could have just stepped on some other kind of service that is open because a number of mini conversations are running. It could have gone into Gmail by mistake. Why does it not mix up things? Now in the second slide, I have just tried to explain if a building has number of rooms, it is very similar to our devices which are running number of services, and each service can have a number which is the port number, similar to what a building has several rooms with room numbers. The next slide is about a web server and the services that run on it as well. Here I'm actually trying to make you accustomed to the different components that goes in whenever we are trying to establish a network connection, what actually responds to us, where we are sending our requests. So hence I have included a slide that shows you a web server situation. So a web server, you can consider it to be a supercomputer, a computer that has answers to all your questions. If you search for something, if you ask your web server that please show me the website for this particular thing, for this particular item, it gives you the response to it. And it has number of services running on it. Depending on your request, that particular port or that particular service listens to your request and sends you an answer. That's more or less overall what goes into questioning and answering or the client-server interaction procedure. Now, why do we even need ports? Ports are needed because one computer runs many networked applications at the same time. They allow multiple services to work together without mixing up of data. I think by now you have received the answer to the question that I had asked in the first slide. So the message that came off WhatsApp, that particular data, exactly knew the destination port number of where it has to go. Reason why it did not mix up with any other services that were running, because it had its destination clear and it also knew the source it was coming from. Now let's learn a little bit about the TCP and the IP model. I'll not be going in depth because it's a big topic in itself, but I'll be explaining it well enough so that it helps you understand ports completely. So if you Google it up, also I'll be attaching the TCP and the IP model on my screen right now. You will see it has a number of layers. It has the application layer, the transport layer, the internet layer, the network layer, and finally the physical layer. These layers show nothing but the journey of a data packet when it starts from its source and it reaches its destination. All that happens to it, all the important things such as the ports, the IP address which are attached to it, the way it changes forms so that it can be received on the other hand is described by this entire model. So the application layer is responsible for how you want to say something, how you're sending your request. So if you search for something on your web browser, for example, google.com, the application layer first determines the protocol that will be used. For example, let's take it HTTPS here. It then checks its own cache, goes to the DNS server, gets to know the IP address of google.com. It then also starts framing a message or the request that will be sending to the server so that the web page that you're trying to load loads up on your screen. Now in the transport layer, which is the layer right after the application layer, the port numbers are assigned. So the message gets included in it, the source port number, the destination port number, so that the message exactly knows where to hit and where to get the answer from, and where to come back to on the same device when it gets the answer. Now let's take a look at how many port numbers do we actually have and how many categories do we have under them. We have a total of 65,535 ports, and the categorizations are as follows. So the first categorization are the well-known ports. So the ports 0 to 1023 come under well-known ports. They are well-known since they are used by standard and widely used services. So there is a body named the Internet Assigned Numbers Authority, or the IANA, which is responsible for assigning these port numbers to these services. Few of the examples for this are HTTP having a port number of 80, HTTPS having a port number of 443, FTP having that of 21. So since they're reserved, tomorrow I can't come up with a new port number for HTTP. It will always and always be 80. Similarly, that's the same for the others that I had named. So what do I actually mean by saying HTTP has a port number of 80? Whenever I want to load a web page or talk to a website and I want to see it on my screen, and maybe that website is following HTTP protocol, okay, so I'll be interacting with the web server that is hosting my website. So when I send the request to my web server, it'll send me a response, after which I'll be able to see the website on my screen. So now the web server also has a number of mini conversations open on it, just like my laptop. It has number of tabs on it. So I need to send the request to the correct place. So I'll go and knock the door of port 80, which actually has the website that I want to see on my screen. So that is what HTTP has a port number of 80 would mean. And when the request or when the response to the request will come back to me, it'll have a source port number of 80, and the destination port number will be the port number of the particular tab that I have opened on my screen. So that way it knows not to mix up with other services and it shows up on my screen. Next up, we have registered port numbers, which fall between 1024 to 49,151. They're used by specific software applications which are created by companies or developers. They must be registered with IANA to avoid any kind of conflicts. There can be a situation of conflict because they are not as reserved as well-known ports, but they are semi-official. Few of the examples here are the MySQL database, which has that of 3,306, Microsoft SQL Server, which has 1,433. Next up, we have my favorite, the dynamic or the ephemeral port numbers, which range from 49,152 to 65,535. Now, while I explain dynamic or ephemeral port numbers to you, they're also known as temporary port numbers. I would also like to explain you the entire procedure that goes on behind assigning port numbers whenever we search for something on the internet. So whenever we search for a website on our browser, let's take it as Lenovo.com. I'm searching for that particular website on my screen. Now, probably I'm visiting Lenovo.com for the first time. If I would have visited it before, the IP address of it would have been stored somewhere in the cache in my device. But it's the first time I'm visiting Lenovo.com, so I search for it. Now, what happens is, when I open a tab and I search for something, the operating system of my device gets a signal that a networked connection will be established right now. So a port number has to be assigned to it so that whenever some response comes back, it will know where to come. For example, my operating system assigns a port number which says 50,132 to this particular tab where I had searched for Lenovo.com. Now my web browser doesn't actually know the IP address to it, so we need to hit or knock on the door of the DNS server. So now when this request of I need to see your website leaves from my device and reaches the DNS server, it has a source port number of 50,132, I think that is what I had mentioned, and a destination port number of 53. DNS has a port number of 53 where it is listening for incoming requests and it will send you the response from there. So when I see that the IP address is present in the DNS server, that IP address comes as a response to me, to my device. And at that time, it has a source port number of 53 and a destination port number of 5132. Now, since I have the IP address, I know that this IP address is of nothing else but the web server, the IP address of the web server that is hosting my website or the website that I want to see on my screen. Now, I send the request to the correct destination, which would be that web server, and my request will have a source port number of 50,000, I think, 50,132, and the destination port number will be 443 or 80, whichever protocol is being used here. When the response comes back from that particular web server to my device again, it will have a source port number of either 80 or 443 and a destination port number of 50,132. That's exactly how the entire journey is covered, and I get to see the website on my screen. That's all that I decided to include in part 1 of the port series. It won't be as long as a series. I think there'll be one other video which will discuss the security aspects of ports. And also I'll be showing you how to identify different kinds of ports, what kind of commands you can use on Linux to detect which ports are open, which are closed, which are filtered, and more. You can let me know on any kind of feedback, on any of the things that I should improve on, or anything that you found confusing conceptually. That's it for now. Let's see each other again on the next video.